to the first part of our notes. It says, where does it say this? It says someplace that the argument has to be positive. I'm not seeing it right now. You see it?
Since x is a base and a would be the base, it has to be a positive real number. Would that be what you're looking at?
No, because A, for this problem, A is a base. You're right about what you said, but X is the argument. Someplace it says that it has to be positive, I think. Well, it has to be positive. I know it says it someplace. For the properties of logarithms, this is the second part of the notes. And these problems, the arguments are m or n. And notice that it says, suppose m and n are positive numbers. So it has to be positive. Your arguments have to be positive for these properties to work. So even though algebraically we got plus or minus, it is just plus. I'm just emphasizing it for your notes. You don't have to put a plus when you actually do problems, just emphasizing. Number 4, log base 8 of 48 minus log base 8 of w equals log base 8 of 4. Ideas? Did you say that again? I didn't hear you. Left to right, top to bottom. You're saying, would this here cancel out? Oh, I see. No, because the arguments are different. If these arguments were both 48, perhaps.
Log base of a of 48 over w equals log base of 8 of 4.
What property says that we can do that, sir? Quotient property. Instead of looking at this as left to right, look at it as right to left. We have two different arguments we're subtracting, and then we can write that as just one logarithm where it's a quotient. Yes, I wasn't joking when I said earlier. Left to right is top to bottom. Reading it from left to right, 48 comes first. Reading the fraction from top to bottom, 48 comes first. Was that what your initial question was? I knew that's what your question was. Please note, I did a terrible job of writing this. I want to make sure that we're all on the same page of what these numbers are. The 48 divided by w is regular size. 4 is regular size. The little 8s here are supposed to be subscript. You all with me? Yes, sir. Who's your buddy? Thank you. Continuing with this problem, use the property of equality again. Since both sides have the same logarithm with the same base, you can just take the argument on the left, set it equal to the argument on the right. These are all regular sized numbers. There's no more exponents or subscripts. Multiply both sides by w, and you get 48 equals 4w. Divide both sides by 4, and you get w is 12. So just a quick review of what this question is asking. This question up here is saying 48 divided by what number is 4? It's just written in a really strange way. 48 divided by what number is 4? Number 5. X is already by itself. It's great. We need to figure out what X is, and in the most simplified way that we can. Anyone have any ideas? Snorlax?
Yeah, put the 10 to a 1/3.
What property says you can do that, sir? I think it's just definition of rational exponents, which was in an earlier section. Well, let me make sure that this one here is subscript. This one here is a regular size. This 1/3 is an exponent. Okay, so how does that help us? Yes, ma'am. Log ID number 1 says that whole thing just becomes 1/3. Now, if that doesn't make sense, why would that equal 1/3? It doesn't make any sense to me. Let me explain it to you, and I think it's going to make perfect sense. If you recall what logarithms are, what this problem is saying, I got a lot of markings up here. It's saying that this 10 to what exponent, because that's what this x is, to what exponent, would equal 10 to the 1/3. 10 to what exponent would equal 10 to the 1/3? Obviously, it would be 1/3, because a third equals a third. Number 6. Something that I hope that you picked up in the last couple examples. If there are coefficients in your problem, and you're trying to add logarithms, you need to get rid of those coefficients, because you cannot add them. You cannot use the product property if you have coefficients. Snorlax? Great idea. Move the coefficient to be an exponent for the argument. Simplify those arguments. Yes, sir? Four to the third is 64. 3 to the fourth is 81. Now we're going back to the product property. When you're adding two logarithms that have the same base, in this case they have 7 as their base, you are allowed to multiply the arguments. So we can write this as log base 7. 64 times 81 is 5,184. I did use the calculator for that. Then it takes us back to the property of equality. If you get one logarithm on each side of the equation, and they don't have coefficients, which these don't, and they have the same base, you can simply say that the arguments are equal to each other. So what this question was really saying at the beginning, 4 cubed times 3 to the fourth equals what?